Okay, so this section is called line integrals. This is section 18.2, line integrals. And this is on page 972 of your textbook. So what is a line integral? Okay, so a line integral is just the work done as a particle moves through a force field. Okay, so that's what a line integral does. It's just the work that's done as the particle moves through a force field. So if a smooth curve C is given by x equals g of t and y equals h of t, where t is between A and B, and our f of xy is continuous on our domain, then our line integral looks like this. So it's the integral over the curve of your f of xy dx. I'm sorry, ds. dx is going to be next here in a minute. This is ds. Okay? And basically that's just a up to b of f of our g of t, comma, h of t. Okay? That looks awful. Let me fix this. That was our g of t, h of t. Okay? I don't know why I put that outside parenthesis on here. Okay, so it's the function g of t, h of t, times the square root of g prime of t, quantity squared, plus h prime of t, quantity squared, dt. Okay, where our ds, okay, is given by this piece right here. Okay, that's what our ds is. Okay, it's given by that piece right there. Okay, so if we do the line integral over that curve of f of xy dx, that's given by a up to b of f of g of t, comma h of t, g prime of t dt. And if we do the line integral over c of f of xy dy, well, that's given our a up to b, or c up to d, if you want to think of it as c up to d, of f of g of t, comma h of t. Oops. Clean this up, make this look a little bit better. Then this is going to be h prime of t dt. Okay, and if we want to know the mass of a wire, if we're trying to calculate the mass of a wire, this is going to be m over our curve of our xy ds. Okay, so let's look at an example. So I'm going to parametrize for our x equal t. Okay, so here's our example. Okay, if I have the line integral over our curve of 3x squared y dx plus 2xy dy, where y is equal to 1 plus x squared from the point 0, 0 to 1, 2. Okay, so that's our problem. Okay, I'm going to parametrize this x equals t. So what I'm going to get is I'm going to get the line integral over C of that 3x squared y dx. This is our, if you want to think of it, this is our x prime. That's our dx. That's supposed to be an arrow, by the way. This is supposed to be our x prime plus the line integral over the curve of 2xy dy. Well, that's kind of our y prime, okay? Again, y was equal to 1 plus x squared. Well, that's the same as saying 1 plus t squared because x is equal to t. Since x is equal to t and t is equal to 0, 1, because that's our x coordinate, 0 to 1, okay? All right, so let's look at this. All right, so we're going to have 0 up to 1, because we're dealing with our dx, of 3x squared. Well, x is what, t? So this is going to be t squared, and our times our y. Well, what is y? Y is 1 plus t squared, okay? And then our x prime is going to be 1, because what's the derivative of x? Well, that's just 1, okay? Plus 2t, okay? 2 times t, okay? Times our y, which is 1 plus t squared, times our dy. What is our dy? Well, that's our y prime. Well, what's the derivative of 1 plus t squared? Well, that's 2t and dt. Okay, so this is our y prime. This is our x prime. Okay. All right, so let's look at that. So this is 0 up to 1 of, let's go ahead and multiply this out. This gives me 3t squared times 1 is 3t squared. 3t squared times t squared is 3t to the 4th times 1, which just stays the same. Now I have 2 plus 2t times 1 is going to give me 2t. 2t times t squared is, let me just go ahead and multiply this all up. 2t times 2t is 4t squared. Okay, so this is 4t squared because I'm doing 2t times 1 times 2t. So that's 4t squared plus 2t times t squared times 2t is 4t to the t times t squared times t is t to the 4th. Okay, and this is all dt. This is all dt. So if you want to think about it like this is all dt. All right, so let's clean this up a little bit more so I'm not doing a bunch of these. So I have 3t squared plus 4t squared, that's 7t squared, and then I have 3t to the 4th plus 4t to the 4th. Well, that's 7t to the 4th. I mean, I could have just done each of these, but that would have been a mess just to do. All right, so let's do this. This gives me 7t cubed over 3 plus 7t to the 5th over 5. And that's from 0 up to 1, right? So this gives me, when I plug in 1, this gives me 7/3 plus 7/5, and then minus 0 minus 0, because when you plug in 0, those go to 0, which gives me, let's see, common denominator of 15. So I have 35 plus 21. So this gives me 56/15 is the answer to this problem. Okay, so that would be our answers, 56/15. So on page 980, you're going to do problems 1 through 6 and problem number 9. Okay, so again, we're going to parametrize this for x equal to t. And the reason we're going to do that is because otherwise we'd have x's and y's, which would be really challenging to try to do. So just change all of your x's to t, which is what I did here. And then we're dealing with x equals t, so t is equal to 0 up to 1. This is our dx is our x prime, our dy is our y prime, and then we calculate it from there. All right, good luck.